Hello students. So today we will be discussing the key for our 2022 Neet paper, right? So regarding the physics part, if you are checking and if you would have wrote the exam, you would have felt very easy this year, right? So comparing with the last years, like this year, physics was literally easy, but what you would have faced is like you would have not found time to solve the questions actually. So to comparatively, if you are if you found time to solve these questions, it would have been very easy actually. Some questions are very direct, and some questions the answers might be arriving at a very few steps if you know the tricks and strategies to approach the question, right? So let us discuss the key points and how we can deliberately get the answers like in an easier manner in this 2022 NEET physics, right? So we can start now. So the first question here it is asking the graph which shows the variation of the de Broglie's wavelength of a particle and its associated momentum. So we know very clearly when I say about the de Broglie's wavelength, we have the formula. So de Broglie's wavelength is given by h by p. So this p is nothing but the momentum, h is nothing but the Planck's constant, right? So this is actually a direct expression from de Broglie's hypothesis. So this gives me like the wavelength is inversely proportional to my momentum. So this gives me like the wavelength is inversely proportional to the momentum. So let us try to eliminate the options. So of course the first option, this because the plots are drawn for wavelength as well as the momentum. So we don't have the first plot because it is comparatively like it's a wrong mapping. And let us go to the third plot, which is actually we can see the momentum is increasing with respect to the wavelength. So like the wavelength value is keeping on increasing with respect to the momentum. That is also wrong. They are inversely proportional factor. Either it could be 2 or 4. But we know very clearly when we get an inverse factor, the graphical form is actually this way, right? So it is not actually directly linear. So it is like in the form of exponential, right? So this fourth option will be correct. Our next question, as the temperature increases, the electrical resistance dash. So this is a very direct question from NCRT. So here we can very clearly see if the temperature is keeping on rising, the resistivity of metals will be increasing. So of course, let me try to find where the option is here. So increases for both conductors and semiconductors. No, this might not be the option. So decreases for both conductors and semiconductors. So what I prefer is generally you should try to eliminate first. If you don't have an idea, if you're a little confused with the options, try to eliminate and try to figure it out like the leftover options, like get the option with the leftover options, right? So here they very clearly say increases for both conductors as well as semiconductors. But you know, in type of a semiconductor, we have two types in a semiconductor. One is the intrinsic semiconductor, where by increasing the temperature, we make the conductor to conduct actually, right? So in case of intrinsic semiconductor, by increasing the temperature, we make the semiconductor to conduct. Of course, when this is a condition, when you try to think, so this might not be the option which the question is asking. So decreases for both conductors and semiconductors. So this is not actually, this is decreases in even conductors. No, when the temperature is raised in conductor, of course the resistivity increases. We know this, right? So basic ideology, we know this. So this might not be the option. So increases for conductors but decreases for semiconductors. Increases for conductors but decreases for semiconductor. Okay, let me keep this an option. So decreases for conductors but increases for semiconductors. So again, this is not the option because decreases in conductor they are saying trying, so this might not be the option. The only way the correct answer should be C, right? So I'm trying to move the question paper in a part where I'm trying to eliminate the rest of the wrong options and getting the correct option, right? So further, third question, let T1, T2 be the energy of an electron in the first and second excited state of an hydrogen atom respectively. According to the Bose model of an atom, the ratio of T1 and T2, so like maybe T1 is the tissue. So they're trying to ask in the first excited state to the second excited state. So first excited state means we say that to be the 2 because n, the quantum number starts with 1. So from the first level, if it is the first excited state, if you are moving, that will be n is equal to 2. And the second excited state from n is equal to 1 will be n is equal to 3. So the second excited state will be n is equal to 3 and the first excited state will be n is equal to. This is the first fact you should first remember. So let us take this to be the values of n, and clearly we can try to solve this. We know the energy in the nth orbit, like maybe an energy in the ground state or in the nth orbit is given by energy in the ground state divided by the n square. So which means energy in the state is inversely proportional to the value of the quantum number. So by this, I can try to say the first excited state is n is equal to 2 and the second excited state is n is equal to 3. We can try to find the ratio now because the T1 and T2 are nothing but the energies. So T1 by T2 is directly given by n2 square by n1 square because they're inversely proportional by this relation. So it is very clear, like they'll be like getting a reciprocate. So n2 square is actually here. The n2 is actually 3 actually. So the second excited state. So that will be 9 divided by 4. So the correct option will be, of course, the fourth option. 9 is to 4. A very direct question again. So the next question, fourth question, two objects of mass 10 kg and 20 kgs respectively are connected to the two ends of a rigid rod of length 10 meter with a negligible mass. So understand this keywords here, negligible mass. So whenever you see a question, try to underline the keywords first. Try to underline the keywords negligible mass. So the mass doesn't matter here. So suppose if the mass would have been mattered, like we have to go with the center of mass of the rod also even. But here that is negligible. So very good. So the distance of the center of mass of the system from 10 kg masses. Okay. So whenever you get a question like this, so directly get into a trick. So we have to place this entire thing in our axis, in our linear axis, where one corner should margin with our origin and the other side, like the length says like it is like one is of 10 kg and one is of 20 kg respectively. So of course, the total length is 10 meter actually. So we can very clearly see if this is 0 and 0, this will be 10 comma 0. So one is placed, let me call this to be the A, one is the other one is the B. So A is actually placed at a 0 comma 0 and B is placed at 10 comma 0. So let us try to find what is the center of mass by this. We know the center of mass along the x-axis is given by m1 x1 plus m2 x2 divided by m1 plus em2, right? Very simple. So when we try to solve it, like we know the values of m1 is 10 and the position for it is 0. So m1 is 0 and m2 is actually 20 multiplied with 10 and divided by m1 and m2 adding the masses. So the final answer will be like 200 divided by 30. So which is 20 by 3 meters. Very simple direct questions. So we don't get any complexity here. Moving to the next question. The ratio of the distance traveled by the free falling body in the first, second, and third second. It's a very simple kinematics question. So when you know the trick here to solve it, so you can get the answer very directly here. So we know the general formula for the distance traveled by the nth second is given by 1 by 2 u plus 1 by 2, sorry, u plus 1 by 2 a into 2n minus 1. So this is the formula for giving the distance traveled at the nth second. And here they say the ratios of distance traveled by the free falling body, underline, it's a free falling body. So instead of a, you should substitute g, which is due to the acceleration due to gravity. And it is like in the first, second, third, and fourth second. So we need to substitute n is equal to 1, n is equal to 2, n is equal to 3, and n is equal to 4 on the above equation. And of course, u will be 0 in a free fall condition. So it is very clear, like the question is asking a direct, that doesn't matter, like it is a direct sort of question. So u approaches 0 always here in this case. And let me try to figure it out. So instead of like they're asking for 1, 2, 3, 4. So you have to substitute for the first, second, third second, and fourth second. And instead of g, you should take a, you should take it as g because it's a free fall condition. On doing this, finally you will be getting the answer to be, so it's very clear, like the answers will be on the range 1 is to 3 is to 5 is to 7, right? So I think I no need to solve this. Actually, it's a very easy direct format. So instead of n, you are trying to substitute 1, 2, 3, and 4. So after doing this, try to compare in the ratios which they are asking. So if you're directly comparing the ratios, you'll be getting the ratios 1 is to 3 is to 5 is to 7. So I'm just giving you the trick to solve this question, right? And moving to the next question, the ratio of the radius of gyration of the thin uniform disk about the axis passing through its center and a normal to its plane to the radius of gyration of the disk about the diameter. Yes. So they're asking again the ratio format. So guys, listen, this sort of questions were repeatedly in the exams for the past years, right? So like the ratio format in this is from the system of particles chapter. So in the past years, if you're asking me like this sort of questions were keeping on repeating, and this is somewhat a repeated question here, I can just say, right? So here we know the moment of inertia topic. So we know the radius of gyration. So radius of gyration is the distance between the axis of rotation and the entire mass of the object where it is acting, maybe the center of mass. So the distance between the axis of rotation and the center of mass is actually called as the radius of gyration. So like this is a fact, like common fact which we know, right? So of course we know the expressions for radius of gyration even. So radius of gyration is given by I is equal to mk square. So this is in terms of radius of gyration relatable with my inertia. So here they're asking we need to consider the uniform disk in two situations. One is along the axis, like maybe the inertia along the axis passing through the center, and one is like the point where the axis is passing through the diameter actually, right? So we know the moment of inertia for these two particular cases. So let us try to get it. So in case of the first, when I try to say the inertia for the first case, when I say the inertia is passing along the axis through the center and normal to the plane of the radius of the disk. So this is given by the equation 1 by 2 mr square. So I would have studied this. So this is given by the inertia which is equals to half mr square. So here instead of this trying to compare this equation with my general equation relation with the radius of gyration, so I is equal to mk square. So you can very clearly see I, like when I directly compare, instead of k square, in the place of k square, in the place of k square, I am having 1 by 2 r square. So the value of radius of gyration, because k is nothing but the radius of gyration. So k will be is equals to r by 2, r by root 2, sorry. So the radius of gyration for the first case is r by root 2, guys. Very simple. The similar case, try to solve for the next situation. So they say the disk about the diameter. So we need to find the radius of gyration along the diameter, right? So for that we have the inertia formula. So I2, sorry, I2 actually is equals to 1 by 4 mr square. So m1 by 4 mr square. So again, I'm trying to make it very simple. This inertia is along the axis and it is like passing through the diameter actually, right? So when I get a circular disc like this, so which is having some area. So the two situations here is one is like maybe the inertia is along the center. So this will be the center of the disk, and another is along the diameter. So another is along the diameter. Like so, this is the second case. One is initially along the center, and the second case is along the diameter of the disk, right? So we have the axis of rotation to be in the second case like this, and in the first case it will be along the axis. It will be like this, right? So the two different cases we have two different inertia formula. So it is 1 by 4 mr square, and I2 instead of, in this case if we are trying to solve for the gyration, so instead of k square we have 1 by 4 into r square, and k2 will be simply r by 2. And when you try to solve for the ratio, guys, so r by root 2 divided by r by 2, so we'll be getting the answer to be, it's very clearly the answer is to be root 2 is to 1, because r by root 2 divided by r by 2, and the root 2 goes to the numerator. Somewhere I'm getting this answer, right? Next question. The angular speed of the flywheel moving with the uniform acceleration changes from the 1200 rpm to 3120 rpm in 16 seconds. The angular acceleration in radians is actually, it's also a very simple question. We know the formula for angular acceleration. So whenever, my good suggestion, when you get a question, try to first write the formula to find. So to find here is the angular acceleration. So angular acceleration is given by alpha. So angular acceleration is nothing but the angular velocity, that is change in angular velocity by time. So the angular velocity final minus angular velocity initial divided by time will be giving you the angular acceleration, guys, very directly. So we know what is angular velocity from the given relations. So it is changing from 1200 to 3120. So it is like the final. They just give the angular velocity in terms, like in terms of on the frequencies. So we know the elaboration, we know the expansion of omega. So omega is actually 2 pi into frequency. So here in this initial case, the frequency was 1200 rpm, and it is in meter. Try to convert into second, don't directly solve in meter. So let us do it. So 2 pi into f, which is like in case of final situation. So this omega final will be generally given by 1200. So sorry, this is actually yes, the final is 3120. Initial only it is actually 1200. So the final is 3120 multiplied by 2 pi 2 pi by 60, because converting that to seconds. So this will give me the angular angular velocity along my final situation. And initially the same way if you're trying to do for the angular velocity along the initial path, so it will be like 1200 into 2 pi divided by 60 again. So we are getting the values in radians per second now. So the unit of angular velocity is radians per second. So trying to substitute here, so angular acceleration, finally it will be under 4 pi. So always check for the options, guys. You don't need to solve the entire thing in the manner like in the entire answer. So check with the options. You are getting the answer directly in 4 pi itself, in terms of pi itself. So no need to get into a direct simplification, right? And next question. An ideal gas undergoes 4 different processes from the same initial state as shown in the figure below. So the process are adiabatic, isothermal, isobaric, isochoric. The curve which represents adiabatic process is the asking only for the adiabatic process. So let us figure out what are the rest of the curves actually, right? So only one thing is adiabatic here, and one other thing is actually maybe the rest of the things isochoric, isobaric, right? So let me take the first curve first. So here the first curve we can very clearly see it is like in a situation where the volume is fixed. You can see this is a place where the volume stands constant, but here we have two different points for pressure. So we have the different points for pressure, but we have a constant volume. So this is called as constant volume. Abhinale, it is like nothing isochoric. Next, checking with this, checking with this fourth point, if you're checking, and it is very clear the volume is changing, but the pressure is remaining constant. Pressure is remaining constant, it doesn't change here. So we call this to be isobaric. Isobaric, we have called that to be the constant pressure, right? And next, 3 and 2 is only left over. So somehow I'm eliminating the options of 1 and 4. So this is called eliminating. So 1 and 4 doesn't answer here because completely they are negligible. And comparing 3 and 2, somehow 3 and 2, the remaining factors is isothermal or adiabatic, right? And we know the equations. The work done in case of an adiabatic process will be greater than the work done by the isothermal process. So of course, if this is the situation, if this is the condition, I can just say this second curve will be my adiabatic process, and the first curve, which is before the adiabatic process, is my isothermal curve. And if you very clearly study the NCERT, this will be a direct question. Actually, it's not nothing like be an somewhere in complexity or somewhere which has been like little complex or it has to be solved. Nothing like that. It's a direct question. So we always compare isothermal process, the adiabatic process. Isothermal, where we say like the system is on a thermal equilibrium, constant temperature, an adiabatic process where the process happening with a complete sealing actually. So there is no transfer of energy between the surrounding and the system. We would have studied this, right? So this is a fact actually. And the option here will be is of course 2. And the third and the next question, sorry. Two hollow conducting spheres of radii R1 and R2, which is R1 is greater than R2, have equal charges. Underline the words have equal charges. The potential around will be very simple question. The potential using a hollow sphere is given by B is equals to KQ by R. So KQ by the radius. So potential is inversely proportional to the radius, of course. Potential is inversely proportional to the radius. And if I say R1 is very much greater than R2, the potential would have been less that much times the second sphere actually, which means R1 radius is very much greater than R2. So the first sphere has a very big, we consider the first sphere to be the largest sphere here, and the second sphere to be the smaller sphere, of course, by comparing with the radii actually. So if we consider that largest sphere is a situation that, of course, the potential when comparing with the largest sphere will be very much smaller comparing with the smaller sphere, right? So which one will be the correct option? You can directly get into the option here, more on the smaller sphere, right? So of course, smaller sphere will be having the more potential because the radius is smaller. The direct question. When light propagates through a material medium of relative permeability epsilon r and relative permeability mu r, the velocity of the is it like again a direct question. So we in general we know the relation, guys. So V is generally given by 1 divided by square root of epsilon into mu. It's nothing but permeability of a medium and permittivity of a medium, right? But we know the relation in general. Epsilon r, the relative permeability is given by epsilon naught. Also, mu r, relative permeability is given by mu divided by mu naught. So trying to equate in this format, I'm finally getting and arriving the equation to be V, which is equals to 1 divided by square root of epsilon naught into epsilon r into mu naught into mu r. So dividing these equations, V will be equals to 1 divided by square root of epsilon naught mu naught into epsilon r mu r. So, but we know this situation, 1 divided by epsilon naught into mu naught is nothing but the speed of light in vacuum, which is nothing but c. C is nothing but the speed of light in vacuum. So automatically I'm replacing this. So V will be given by c divided by square root of epsilon r into mu r. So this will be the direct answer. So very simple solving methodology here, right? So which will be the correct option? Fourth will be the correct option, right? So rest of the options we won't get this because like they didn't give any situation like V is equal to C, of course not, and V is equal to square root of epsilon r by epsilon. This is a complete relation based question, so no need to get into the other fact. So we can directly solve and get the answer, right? Next question, a solenoid based question. Of course, every year we expect solenoid based question. So if you would have revised solenoid, it will be very easy question. Like long solenoid of radius 1 mm has 100 turns per mm. So 100 turns per mm. So kindly understand this fact here. 100 turns per mm, which means they are trying to give the number density directly. So 100, so number density is given by 100 turns per mm. So when I change that mm into meter, that will be 10 power minus 3, the fact here, into like turns per meter now, right? Now this 100 into 100 divided by 10 power minus 3 factor turns to 100 into 10 power 3, which is 10 power 5. So 10 power 5 into iota value, we know that is actually given as 1 amps. So on solving this, B will be actually very simply 4 pi into 10 power minus 2 Tesla. And very clearly, when you try to solve this, substitute the value for pi, which is 3.22 by 7 or 3.13, which is actually 12 point, which is 12.56 into 10 power minus 2 Tesla, right? Next, the peak value of the AC source is equal to the peak value of the AC source, right? We know the RMS value of voltage is given by peak value divided by root 2. So the peak value divided by root 2 is the general equation. Then the peak value is given by root 2 times the V RMS. So by this, the options will be root 2 times the RMS value of the AC source, right? Third option. So these are very direct questions here. Next question. An electric lift with a maximum load of 2000 kgs, a lift, electric lift with a maximum of 2000 kg in lifting passengers as well as the lift, entire lift, it is like 2000 kgs, is moving up with a constant speed. So it's underline this word, it's moving with a constant speed. The frictional force opposing the motion is 3000 Newton. Okay, great. The minimum power delivered by the motor, the minimum power delivered by the motor to lift the water. Okay, like maybe we know that the motors lift the lift actually. So of course they would have do some work in lifting the lift completely. So let's try to find. So the force which is acting on the upward direction, if this is the lift, the force which is acting on the upward direction will be clearly the force which is actually due to the weight, because if downward force is mg, the same normal force will be acting upwards. Here the entire lift is of having the weight of 2000 kgs multiplied with acceleration due to gravity g, right? So 2000 into g will be acting downwards. The same amount of force will be acting upwards, which is nothing but the normal force or normal reaction, and the frictional force will be also acting in the same direction. So trying to add it up, like maybe 2000 g plus 3000 n. So the total force which is acting upward, which is actually 2000 g, which is 2000 into 10, that is g is nothing but acceleration due to gravity multiplied with 3000. So this gives me the total force value acting upward will be 23,000 Newton, because when I multiply 10 with this, that becomes 20,000. So there is 23,000 Newton. So 23,000 Newton. So we got the force value. And of course, we know that power will be given by work done by time, and work done is force times displacement by time, and force in displacement by time is actually velocity. So force into velocity, we have the force value which is just now solved, and we have the velocity at which the lift is moving. And finally, I'll be multiplying the two factors to get the answer 34,500 watts. Very simple, right? Let's next. In next double-slit experiment, a student observes 8 fringes in a certain segment of screen when a monochromatic light of 600 nanometer. So it's like a 600 nanometer wavelength, and maybe a light is being passed. We know the Young's double-slit experiment. It's an experiment for interference topic. So Young's single-slit experiment is for the diffraction. Young's double-slit experiment is for interference topic and maybe constructive or destructive interference ideologies. So Young's double-slit experiment mentioned here, and we have 8 fringes formed. So we have the 8 fringes formed in the first case, and when 600 nanometer light is used. And if the wavelength is changed to 400 nanometer, the number of fringes formed. A very ideological based question, very simple ideology here. So if I take this, might be the screen, and if this is actually L, so total length of the screen, let us take to be the L, and we can say there are 8 fringes formed, which means 8 fringes, which means they're trying to say we have one bright fringe, we have one dark fringe, and again bright fringe, dark fringe, bright fringe, dark fringe. We call this to be the fringes. This is a pattern which is formed in case of Young's double-slit experiment. And when I have a dark fringe, next to that I'll have a bright fringe, and next to dark fringe, a bright fringe. So the distance between two consecutive dark or two consecutive bright will give me the fringe width, right? So this is actually the fringe width actually. So fringe width is nothing but the distance between two consecutive dark or bright fringe. So by this ideology, if I take the total length of this screen to be L, so this L can be simply given by 8 times the fringe width. So it's like we know that what happens here, fringe width is addition. When I say this is a distance between two consecutive dark fringes, so we will be getting to, it's like a fact, we'll have 8 times multiplied. We have the factors that bandwidth will be keeping on 8 times multiplied since we have 8 fringes totally. That's the fact here. So 8 times multiplied with the bandwidth. And we know the bandwidth formula, since let me differentiate this will be beta 1. So because bandwidth here in this case, initially I'm using the wavelength of 800 nanometers, so I need to differentiate this. So bandwidth is given by the formula lambda d by d. And very clearly this capital D represents the distance between the slits and the screen, and D represents the distance among the slits. We have two slits here, and the distance between the slits is given by small d. Distance between the slits and the screen is given by the capital D, right? So this is the first case. And the second case, the same situation I'm trying to compare. So the length will be divided into n times beta 2. I don't know what is the value of n, that is what to be found. So this is multiplied with n into lambda 2 d divided by d. So what I try to do, I try to divide the equations, or I'm trying to equate these two equations. So this is a situation. Finally, my n will be, on solving this, n will be actually lambda 1 by lambda 2 into 8. So on equating this, we'll be getting this relation. So lambda 1 is actually 800. Sorry, lambda 1 is actually 600 guys. So lambda 1 is 600 nanometer divided by 400 nanometer multiplied with 8. So finally, my value or value of n should be 12, right? So the value of n should be 12. So let us make it faster. So a copper wire of length 10 meter, radius 10 power minus 2 divided by root 2 has electrical resistance of 10 ohms. Find the current density of the wire for the electric field strength 10. Okay. So we know the equation of current density. So current density is nothing but current density, which is given by J, which is nothing but electric field. Current density is nothing but electric current per unit area. Sorry, current density is nothing but current per unit area. So current in terms of Ohm's law is given by V by R. So V by R into A. And V, potential in terms of electric field. Since I'm trying to change the equation in terms what does the question says to me, right? So here V is given in terms of electric field. We know that potential is nothing but the gradient. So electric field multiplied with the distance actually. So we know this very clearly. So maybe this factor helping me. So potential is given by E into distance or length divided by R into A. And substituting all the values given, electric field is 10 multiplied with the length is given to be 10 again, 10 meters. No need to convert. Ohms is like 10 resistance. multiplied again with the factor of area. So the radius is given to be this factor. So area of cross section போடுறப்போ that will be pi into r square. So that becomes 10 power minus 2 divided by root pi, which is actually whole square. So we substitute directly what is the answer here. So we are getting the relation, we are getting the final answer to be on solving this, because 10 gets cancelled, and when I square it up, this becomes 10 power minus 4, and pi becomes root pi becomes simply pi gets cancelled. So when 10 power like minus 4 goes to the numerator, that becomes 10 power 4. So 10 power 4 and including this 10, this becomes 10 power 5 ampere per meter square, right? So the dimensions of MLT power minus 2 into A power minus 2 is actually magnetic permeability. So when you use magnetic permeability equations, maybe from our Biot-Savart law, you will be getting the equations directly, right? So these sort of like dimensions which have been asked directly. Every year we can expect the dimensions which can be directly asked in the exams. So somehow we can manage it. Like it's not like everything you should study, everything you should keep in your mind. But if you know the general relation where I can find it out, where it is like actually been there in my syllabus, so automatically you can recall the relation, you can try to solve the dimensions by your own, right? And next question, if the initial tension on the string is double, then the ratio of the initial and the final speeds of the transverse wave, again a question from a wave topic. So they are trying to ask what is the speeds of the transverse wave with relation to the tension. So with relation to the tension, we have a calculation for this. So V is equals to T divided by mu. So this is a direct relation from NCRT. So by this, what I'll try to do, they say like in two situations, one the initial situation and the final situation where the tension is doubled. So let me take this to be the initial position, and the final is actually the tension is doubled. So 2T by mu. And on dividing this to fact, actually they're asking the ratio, dividing this to, finally I'll be having 1 by root 2. So the third option will be correct. So see how easy they were asking. But if you know the relation directly, we can no need to bother. We can directly get the answer within few seconds, right? And half wave rectification, if the input frequency is 60 hertz, then the output frequency will be very clearly, guys. In half wave rectification, the frequency remains same, and in case of full wave rectification, the frequency becomes double. It's a direct path. So 60 hertz means the answer will be 60 hertz. Suppose in the same word is replaced with full wave rectification, that have been doubled, that will be 120 hertz, right? The displacement time graph of two moving particles making an angle 30 degree and 45 degree with the x-axis as shown in the figure. The ratio of their respective velocities, right? So we have two graph, maybe the graph of a displacement time graph, and clearly when you try to find the slope of this graph, that gives you the velocity. First, we must know what are the slope and what is the area covered by displacement time graph. I mean, generally we must know actually, right? So when we are getting it, so directly we can solve the questions in an easier manner. So they're asking what is the ratio of their velocity. So when you try to find, since it is a ratio format question, it's very easy for me. So like what I can do is the ratio is simply, when I try to take the ratio between these two conditions, one is like tan 30 divided by tan 45 respect to the question. So that turns to be 1 by root 3 by 1. So tan 45 is actually 1. So that gives me 1 is to root 3. So you no need to solve furthermore, like no need to get into any complexities. It is very easy for us. So when I try to find the ratio, they're simply asking the ratio. I know in a displacement time graph, the slope is my velocity actually. No need to get into any further topics. So velocity is nothing but the slope. So when they ask for the ratio of their respective velocity, I'm taking the ratio of this slope, because slope in terms is nothing but tan theta always. In case of the graphical form, slope is nothing but my tan theta. The theta, the steepness of this curve is nothing but my slope actually. And even we have furthermore, slope is also y by x. Y by x, the component of y divided by the component of x is also slope. In case like if you know this relation directly, we are getting it direct. That's all, nothing. A square loop of side 1 meter and resistance 1 ohm is placed in the magnetic field of 0.5 Tesla. If the plane of the loop is perpendicular to the direction of the magnetic field, the magnetic flux through the loop, very simple question and a very direct question. And when I have the coil to be like this and the sides are 1 meter, And when I try to find what is the magnetic flux is given by the relation B into A cos theta. And the magnetic field and the area are on the same direction. Therefore, of course, cos would have been 0, that is maximum value. So the flux is given by magnetic field is 0.5 multiplied with the area. So area, we know that for a square is a square, like, which means here is actually 1. So the answer is 0.5 directly. So 0.5 vapor. So understand this: a square loop of 1 meter of resistance 1 ohm is placed on a magnetic field of 0.5 Tesla if the plane of the loop is perpendicular to the direction of the magnetic field. See, this plane is perpendicular to the magnetic field, which means a magnetic field is passing through the plane like this. And understand, if this is the situation, we have the area vector. So this is the plane, means the area vector will be acting perpendicular to the plane again. So this is a magnetic field actually. And even check with this, guys, the area vector will be also perpendicular to this, right? So the area vector is also perpendicular to this. Understand, don't get confused. Sometimes students might get confused. Since the word perpendicular is mentioned here, they will think that the answer, that the maybe the flux might be 0 actually, because when a cos 90 is substituted, that turns to be 0. But here understand, the plane is only perpendicular. The area vector is not perpendicular. See, the flux is giving with the angle BA cos theta, which means the flux and the area vector has been spoken here. And we have to check only the angle with the area vector and the magnetic field, not with the plane, right? So if you are wrongly constructing it like the perpendicular, means if you are substituting cos 90, you'll be ending up and getting a 0 over. That is wrong. So don't do that mistake. Next, the energy that will be ideally radiated by a 100 kilowatt transmitter in 1 hour. So we know the power which is given by energy divided by time, and energy is given by power multiplied with time. A simple relation. And we have the power to be 100 kilo, 100 into 10 power 3, and the time is actually 1 hour. Convert that 1 hour, since the answer is in joule, we have to convert that into seconds, 3600 seconds. On solving, you will be getting the answer 36 into 10 power 7. See how directly they are. Only thing is, you would have not found time. A body of mass 60 grams experiences a gravitational force of 3 Newton when placed at a particular point. The magnitude of the gravitational field intensity at a point. See, this sort of question, suppose you don't have a clear picture what is the gravitational field intensity, try to understand. We have something called as a relation between force and electric field intensity, which is given by E into Q. In our first chapter, electric fields and charges, we have this relation, force is given by E into Q. We know that these forces are analogous to each other. So this force, when I try to even compare with my gravitational force, obviously, so when I try to write the same relation, F is equals to Q is the charge. A charge equivalent in terms of the gravitation is actually mass, right? So mass is equivalent to charge here. So E, instead of E, I'm trying to substitute mass multiplied with Q. So sorry, this is actually charge times, I wrote it wrong, charge times electric field. So electric field intensity, right? So this is the equation. So in that force, which is charge, is actually replaced with mass, equivalent value for in terms of gravitation. And in terms of electric field, we have the gravitational field here, right? So electric field, gravitation. That's the only change we'll have here. So let this be the gravitational field intensity. Let me just use a word Eg. Suppose it can be represented by Eg, gravitational field intensity. So the gravitational field intensity is given by force divided by the mass, and we have the force value, which is 3 Newton divided by 60 grams, that is converted to kg. So it's like simply the force 3 divided by 60 into 1000 to get the answer in kgs, right? So on solving this, 3 table, 320s are, and finally it is like 50 Newton per kg. Very simple. And next question, like, let us solve this question using tricks actually. So we very clearly know like the trick, the order of the electromagnetic spectrum. So let me tell you the trick. A red man in violet uniform with X gun. So red man in violet uniform with X gun. So this will be the order. This will be the decreasing order of wavelength, starting from the radio waves. Next is micro. Next is infrared, violet, UV. sorry, this is actually visible spectrum. So Redman, R is for radio, M is for microwaves, I is for infrared, V is for visible spectrum, U is for UV rays, X is for X-rays, and G is for gamma rays, right? So we have the 7 spectrums here. So see, this is order, I said there is a decreasing order of wavelength, and it is an increasing order of frequency, right? So try to see the options here. We have the radio waves, which is like in the order, like which has a maximum wavelength. So here, let me choose the maximum option with the maximum wavelength, because radio waves is starting, right? So let us take this first. So of course, this is matched with this. Let us go to the last thing, which is actually X-rays. So X-rays is actually like in the order below, which means it should have the minimum wavelength. So in this option, which has the minimum wavelength, I'm trying to equate this X-rays with this and selecting the options relatable to this. So A should have 2 and D should have 1. A should have 2 and D should have 1. So fourth option. That's all. No need to check even with the others option. You can directly get into the setup like this. So if you have a very small basic understanding, no need to mug it up, no need to just analyze anything seriously. So if you're getting the ideological fact, you can get the answer. Next question. A shell of mass m at rest initially, it explodes into 3 fragments. It is explodes in 3 fragments, having masses into the ratios of 2 is to 2 is to 1. If the fragments having the equal masses fly off along the mutually perpendicular directions with the speed v, the speed of the third lighter fragments. So when I have one larger mass split into 3, actually, let us take they have been mutually perpendicular, traveling with the same speed v, which means one particle, if it is going with the velocity v in this direction, the other will be going mutually perpendicular to this direction. And of course, the third particle will be going in as a resultant. So this will be, let me take this, the velocity is to be v dash. So we can very clearly see the particle is splitting into 3, and in this 3, the rest of the 2, which is having the same velocity, is moving along mutually perpendicular direction, and we need to find what is the speed of the third lighter fragment, which is nothing but the v dash in this case, right? So v dash can be easily found here. So they're asking for the speed, and by the conservation of momentum, what I can do here, by the conservation of momentum, I can just clearly say the resultant momentum of the third particle, maybe the resultant of these two cases is nothing but the resultant of the third particle. So the resultant p dash or the momentum is given by momentum of the first particle square plus the momentum of the second particle square. I'm just trying to use the resultant vector concept here. So p1 square plus p2 square, which gives me initially, try to understand, guys. And this square root momentum is nothing but the product of mass times velocity. So mass times velocity. So p1. So this is the first particle which is moving in. This is the first particle. This is the second particle. And the question says the first two particles will have the mass 2, 2, which means like the entire mass, they will have the value of 2. So let me take that value to be 2mv whole square plus 2mv the whole square. So finally, this will be like when I'm squaring this, it is like 2 times of 4m square v square, which is actually I'm taking the entire thing outside the root, which will be like 2mv into root 2. So this will be the resultant momentum, and the resultant momentum, let me substitute this. Let us try to solve it. So that is like mv dash, expanding this resultant moment, that is mv dash, which is equals to 2mv root 2, and gets cancelled, and the resultant v dash will be simply 2 times of 2 times of root 2 into v. That's all. 2 times of root 2 into v. Right? So the options will be 3. Yes, I'm making it very simple. I'm not making it very complex. Only thing is I have to understand the question clearly, and I can use any multiple ways, because here, since the speed is being asked, this concept is actually, whenever I say the particles have been separated, splitted, so we say the conservation of momentum is acting there. So by the conservation of momentum, initial momentum should be equal to the final momentum, and this conservation of momentum works with this case even, right? Fine. So moving to the next ideological fact. A biconvex lens have the radius of curvature 20 centimeter and the refractive index of the material is 1.5, the power of the lens. So a biconvex lens have a radius of curvature 20. So we know when the radius of curvature and the refractive index is given, we have to use the lens maker formula. So that's the only way. So 1 by f which is actually mu minus 1, 1 by R1 minus 1 by R2. So on substituting, I'll be getting 1 by F, which is equals to 3 by 2 minus 1 into 1 by 20 plus 1 by 20. Why I'm substituting 1 plus 20? Because one radius of curvature will be positive, another will be also positive. So like the other side will be negative. So if this is a convex biconvex lens, and if I try to take this side, which is having the focus on this part, and the second face will be having the focal length on the left hand side. So if this is the left hand side, obviously the radius of curve, this surface is having the focus length on the left hand side. If it is on left hand side, that should be negative. So it will be like minus 1 by 20, and minus here in this formula gets cancelled. That becomes 1 by 20. So on solving, 1 by F will be given by 1 by 20. So F is actually 20 centimeter. So F is 20 centimeter, which is actually, then power will be is equals to 100 by 20. Solving this will be 5 diopters. So plus 5 diopter. Moving to the next statements. Biosavart. This is a very common fact, like maybe not now, but previously this was statement based questions was there in the exam. But very after a long time, they were asking the same sort of statement based questions here, right? So the Biosavart gives us the expression for the magnetic field of an infinitely small current element ideal of a current carrying conductor only. Yes, this can be taken correct. Yes, when we write the expression for Biosavart law, so we say like magnetic field due to an infinite small current carrying conductor is given by mu naught by 4 pi into I dl sine theta divided by r square. And when I check this, you can see there is an infinitely small current element, and by this, what is the magnetic field at a point? This is given by the Biosavart law. Next, Biosavart law is analogous to a Coulomb's inverse square law of a charge q, with the former being related to the field produced by a scalar source ideal, while the latter being produced by a vector source q. So no, see, we consider this to be the scalar source, and this ideal is a vector source, because in order to give the direction of the magnetic field, we consider this ideal entirely to be a vector source, and this R again to be a vector source. The cross product of this dl cross R gives the direction of my magnetic field, guys. So this is a relation which we studied already. So when this is a relation, this statement is completely wrong. So we can say the statement 1 is correct and statement 2 is incorrect. We should be careful about the statements. Moving to the next question. So we have a relation-based question from the nuclear chapter. In this given nuclear reaction, the element X. So we need to find what is the element X. So element X, let us take the atomic number to be Z and mass number to be A. Plus we have a positron. We have the positron which is having the atomic number to be 1 and the mass number to be 0. Plus neutrino doesn't have any fact. Right? So by the conservation, the mass numbers conservation, let me check it out. So left hand side, we have the mass number 22, and the right hand side should be like the factor, since it doesn't have any sort of positron doesn't have any sort of mass number, so that should be actually then repeated. So that should be like 22 again, and checking with the mass number. So this is the mass number actually, an atomic number we have left hand side 11, and that goes to the right hand side of the product side. We have an element plus a positron. Positron takes one of my protons, so which means this X should have 10. By conservation, this X should have 10 and positron has taken 1, because the left hand side has 11, and by conservation this has to be split like 10 plus 1. So let me check the options. This X should have the atomic number 10 and mass number to be 22, so which is the third option. Plane angle and solid angles are, plane angles and solid angles are supplementary angles, which you would have studied in our first chapter as a very basic question. You can see that basics were been helping us to solve this. Units but no dimension, dimensions but no unit, no units and no dimension. Of course, try to eliminate the option. They have units. We know the unit for plane angle radians and solid angle steradian. So this option is not the answer. Both units and dimension. Let me have the rest of the options I should think. And no units, and it is also eliminated because they say there is no units. They have units. So try to eliminate. So either it could be 1 or 4. 1 or 4. Either they can have units but no dimension, or they can have both units and dimension. So let us solve it out. So plane angle or the formula, plane angle is given by arc by radius. So arc is also the length and radius is also the length. So when I try to substitute the dimension, they cancel out each other. So but they have unit. And for solid angle, the formula is actually solid angle is given by area by radius square. Again, area is actually L square and radius is also L square. So again, the dimension gets cancelled. So the options will be they have units but no dimension. They have units but no dimension, right? So they don't have both units and dimension. They have units but no dimension. So the angle between the electric field lines and the equipotential surface is a direct statement. When you study the equipotential surface property, you would have studied this. This is 90 degree, right? So you should be careful about this. Very simple based question. This is the direct question. The angle made by at every point on the conductor, the equipotential surface and the electric field lines will be right angle to each other. So this is the electric field and this is the equipotential surface. So always they'll be right angle to each other. A light ray falls on a glass surface of refractive index √3 at an angle 60, and the angle between the reflected and the refracted ray. If you don't have a clear picture, let us try to solve it very clearly. If this is a surface, I said this angle with respect to the normal is actually 60, the incident angle, and this medium has a refractive index √3, and we say some of the light would have been reflected with an angle R, and some of them would have been reflected with an angle of reflection R1. Let me take this to differentiate this. I'm taking this to be R1 and the refracted angle to be simply R, right? So this is angle of incidence, this is angle of reflection, and this is the refraction. They're asking angle between the refracted and the reflected ray. So it is very clear. Let us find the angle of the refraction first to get the answer. So it is given by my Snell's law. So angle of incidence into the refractive index. So N1, which is nothing but the air medium. So we have sine 60, which is equal to the refractive index of the medium multiplied with sine R. So sine A by sine R, sine 60 is √3 by 2 multiplied by N2 by N1, and the 1 by √3 in the side of the 4, that becomes 1 by √3, which is equals to sine R. So √3 gets cancelled. Sine R is 1 by 2. So R is equals to sine inverse of 1 by 2. And sine inverse of 1 by 2 is nothing but 30 degree. So I am getting the angle of refraction to be 30 degree. If this is 30, the remaining angle would have been 60, because we have this normal is making angle 90. In that 90, and this angle is 30, and the remaining angle will be 60. And of course, if this is 60, and by the condition, I can just say angle of incidence will be equal to the angle of reflection in case of reflection. This angle made by this will be 60, and the remaining will be 30. And total, they're asking what is the angle between my reflected ray and the refracted ray. So this is my reflected ray, I'm checking, guys, and this is my refracted ray. And you can totally see 60 plus 30 is the angle made by them. So 60 plus 30 is nothing but 90. So 60 plus 30 is nothing but 90. You don't need to keep any equations in your mind. Directly, you can get into the topic, solve the answer with a very confident way, right? Next, PN junction, we are having 3 PN junctions. Like they're asking the circuit A, B, C, the potential drop across the 2 PN junctions are equivalent, which case in Kekranga. So let us check. In the first case, this is forward biased. This is also forward biased because P is connected to positive and N is connected to negative. Forward biased. And in the second case, P is connected to positive. This is forward biased. And in this case, again, P is connected to the negative side. P is connected to the negative side. This means the reverse biased. And in the first case, again, here the third case, in this N is connected to the negative side. This is forward bias again, and again P is connected to positive side. So it is like forward bias. In these two cases, if you are checking, both the junctions are forward biased, which means forward bias. The condition for the same potential drop, the condition is either junction should be forward biased or either the junction should be reverse biased. In these two cases alone, I can just see both the cases are forward biased. And the second case, we have the things to be one is forward biased and one is reverse biased. So the potential drop will be vary actually. They will be not same. So the options will be both the circuits A and C. Both the circuits A and C will be the answer. Next, 32nd question. A spherical ball is dropped in a long column of an highly viscous liquid. The curve in the graph is shown which represents the speed s. See, whenever I take a fluid and if I'm dropping something on it, when it goes into the fluid, we call this condition, the velocity with which the fluid is moving is called as terminal velocity, right? So terminal velocity, in case of terminal velocity, we say the weight of the object is acting downward and the buoyant force and the viscous force will be acting upwards. We'll try to make the object to move upward, where the weight of the object will try to move downwards. So finally, the object will reach the terminal velocity with which it will be moving. And the rest of the equation is this velocity and time period with respect to this. The only option which is more applicable is option B, because after reaching some time, the velocity remains same because this velocity is called as terminal velocity. By the ideology, I am choosing this option. Two resistors of resistance 100 and 200 ohm are connected in parallel electrical circuit. The ratio of the thermal energy developed, right? So we know that power, which is equals to V square by R, and power is inversely proportional to resistance in case, because the circuits are connected in parallel, guys. If it would have been series, I would have taken current relation I square R. But here in this relation, the power is the resistors are connected in parallel, so potential difference, potential remains the constant. So I'm choosing this, right? So if I try to find P1 by P2, so that will be like, it is actually yes, R2 by R1 directly. So value of R2 is here 200 by 100. So that is equals to 2:1. So the answer is 2. So you don't need to get into any difficult complexities here. Directly the questions are getting me the answer. In two monochromatic lights of frequency mu by 2 is incident on a photoelectric material, the stopping potential becomes Vs by 2 and Vs. The threshold of frequency of this material is yes. So understand here, we have the relation of Einstein's photoelectric equation, Einstein's photoelectric effect. So the incident energy H mu is used as H mu naught, which is the work function. H mu naught as a whole is the work function plus the kinetic energy. And we know the kinetic energy in relation with the stopping potential is E into V naught. So I'm trying to substitute here. H mu will be equals to H mu naught plus E into V naught. So trying to substitute, this is a relation which is given in the question. If the frequency is mu and the stopping potential is Vs by 2, so H mu, which is given by H mu naught plus E into Vs by 2. First equation. Let me call this to be the first equation. Second equation, when the incident frequency is reduced into half, my stopping potential turns to be E into simply Vs. So let me call this equation to be the second equation. And when I try to compare these two equations on solving for Vs is the thing which is asked in the question, threshold frequency. So directly I can solve this, equating these two relations, and I'm ending up in getting 3 by 2 into V, right? So try to solve, we can get the answer. Next, if a soap bubble expands, the pressure inside the bubble. So of course it decreases. So how it is given? We know that the excess pressure inside is given by, inside a soap bubble is del P, which is 4T by R. This del P is nothing but my inside pressure minus the outside pressure, which is equals to 4T by R. Somehow, if you want to find what is the pressure inside, this is like P out plus 4T by R. And if you are trying to resolve this relation, this P inside is inversely proportional to the radius. If the soap bubble is expanding, the radius is increasing. If the radius is expanding, pressure is reduced. So pressure is decreased, right? Fine. Next question, 2 points such as Q1 minus Q and plus Q are placed at a distance of L as shown in the figure. So of course, on the what will be the relation here? So we know this is an axial point condition. So an axial point, electric field is given by 1 by 4 pi epsilon naught into 2p by r cube. So the relation with respect to the electric field is r cube. 37th question, the area of the rectangular field so is given by 55.3, breadth is 25 meter, and rounding off value after the current significant figure. Somehow when you try to find the area, so area is given by length times breadth. So length times breadth is actually, length is 55.3 multiplied with 25, and finally I'm getting the answer to be 1382.5 meters square. But checking with the option, I have 1382. So what you will probably do, you'll choose this option, but this is wrong because we have to correct the significant figure here, right? So in terms of multiplication, I have to choose with the least number of significant figures. In these two values, this value breadth is having the least significant figure, right? Least significant figure. And here we have three significant figures, we have only two significant figures. That has to be chosen. My answer should have only two significant figures. So by that, if I'm checking all the options, the only way is the fourth option because it has only two significant figures and it is in scientific notation, which doesn't have any power, doesn't have any significant value, right? So 14 into 10 power 2 will be my answer. Logic gates, and again the area of interest, very good. So let us take this to be the NOT gate, and this is to be and a NAND gate, and A, and the output of this gate will be probably A multiplied B complement because A is going as an input and B is again getting as an input, so that will be the fact. And here one input is A complement dot B complement, sorry, B whole complement, because here the A is just complicated, maybe complemented here, and one input is directly B and the output is NAND, so they'll take a complement. So A complement multiplied with B as a whole complement, and trying to get the output here, so it will be like Y or C. They're giving the C. Let me use C itself directly. So C will be given by A dot B complement multiplying A complement dot B whole complement. Applying the De Morgan's theorem. So De Morgan's theorem says if I have A dot B A complement dot B complement, so this can be written as A plus B the whole complement. So this is De Morgan's theorem. By this, if I'm trying to write this expression, this can be written as A dot B plus A complement dot B the whole complement, right? If you take B common in this equation, this becomes A plus A complement into B the whole complement, and A plus A complement is simply 1. So finally I'll be getting B complement. So C will be simply B complement. So whenever you try to find C, you have to just take the value of B complement, right? So adupadi partana, which will be the correct option. So you can directly say that the options here is like third option will be correct, right? So you can, since the output is a B complement, if it's 0 1, 0 1 is the input given in the B, so that will be an exact replica of this. So this will be the answer. Okay, next question, 39th question. Assertion reasoning. The stretching of a spring is determined by the shear modulus of the material of the spring. Okay. And reason, a coil spring of copper has more tensile strength than the steel spring of the same dimension. So dimension spelling is wrong here. Dimensions, right? So here I can just say, so in case of an assertion reasoning, to relate these two equations, let us try to add a because in between. So let us try to add a because in between. So stretching of a spring is determined by the shear modulus of the material of a spring because a coil spring of copper has more tensile strength than the steel spring of the same dimension. No, this is wrong because this statement should have been vice versa, and this second reason is actually wrong completely. So if you would have got a clear picture regarding this equation, so you would have easily found that second statement is wrong. Assertion is correct, but reason is false, right? So when you try to get use this because in between, and if you are trying to get a proper relation, see when I use this because, if I'm getting the proper reason for the assertion, I can just choose the first option. Illaya, I should not choose it. Illa, எனக்கு வந்து just take the second option, that the reason whether it's correct. Also check sometimes the assertion whether it is correct or not. So you should be very careful with the assertion reasoning sort of questions, right? Fine. Next, an ampere circuital law. We know what is an ampere circuital law, which is helping me to give the magnetic field at a particular point by drawing an Amperian loop there for a long straight wire of circular cross section carrying a steady current. The variation of the magnetic field in the inside and outside region. Okay, inside and the outside region. So uniform. Let us, like when you take this question, like try to eliminate the wrong options first, and uniform and remains constant for both the regions. So what they're trying to say, they're asking what is the magnetic field inside and outside the regions of the wire. So of course they won't be remaining same. because they reduce with the factor. We know that a linear increasing function up to a distance, okay, and linearly decreasing on the outside region, right? So if we are like trying to plot the graph here with respect to the magnetic field and the distance, we will get a steady increase in magnetic field until a particular point, which is nothing but the radius of the conductor. After that, there will be a steady decrease in the order 1 by r. This is the fact. This is a crack which we have to remember. So the third option will be correct. You see, the second and third options are nearly equal, but here in this factor, they're trying to mention 1 by r very clearly. So of course, we have to choose only that option there, right? So no need to go with any other option. So we can choose this because we know the magnetic field is given by mu naught I by 2 pi r outside the conductor. So the magnetic field is inversely proportional to the 1 by r. So that's a fact. I see the LCR circuit of inductance 10 Henry, 10 microfarad of capacitance, resistance 50 ohm is connected to AC source of 200 sine omega t, which is 100 t. The resonant frequency in the LCR circuit. So we know the formula for finding the resonant frequency. You know it, guys. So resonant frequency is given by 1 by root LC, and we are getting the values of L and C. L is 10 and C is 10 into 10 power minus 6. On solving, we are getting the omega value to be 100. And once we are getting the omega value, we can try to get the frequency value. So omega, which is equals to 2 pi f. So it is like f, which is equals to 100 by 2 pi h. So this will be the frequency. And if this is the frequency, I can, if I'm trying to find it out, and this is actually the resonant frequency. Let me make it more clear. This is the resonant frequency. Let me differentiate omega f naught. So the resonant frequency is 100 by 2 pi. So the resonant frequency is 100 by 2 pi actually, right? And if you want to further solve, this is actually 50 by pi. Since my options I'm taking, it is in 50 by pi. So I'm trying to get it in a proper manner. And if the resonant frequency of the LCR circuit is V naught and the frequency of the AC source V10. So நம்மளுக்கு கேக்குறது என்னன்னா resonant frequency இதுவும் என்னன்னு கேக்குறாங்க. So let us check this. Resonant frequency 50 by pi and frequency 50 hertz, and the resonant frequency 50 by pi options மட்டும் நம்ம first எடுத்துக்கலாம். So of course first option is neglected because we have only 50 hertz. That is wrong because 50 by pi should be the answer. So அதே மாதிரி resonant frequency should be 100 by pi. This is wrong. Resonant frequency 50 by pi and 50 hertz. Either 2 or 3 should be the option. So I'm trying to help you out how to eliminate the options first, right? So I'm getting, I solved the answer. I solved the answer for resonant frequency. I'm getting 50 by pi. So let us try to understand. We know in resonance condition, we are trying to tune the circuit to the desired frequency to get the maximum power to the circuit. So this condition is tuned by the input frequency in such a way so that we to obtain, it's like in the tuning condition, in order to get the maximum power. So in the resonance condition, we say XL should be equals to XC, which means that when I try to solve for the impedance is directly equal to the resistance of the circuit, where we am getting the maximum power in case of a situation. LCR circular, the maximum power is obtained when XL is equals to XC, which is nothing but the situation of resonance, right? So automatically I can understand here this input frequency should be equal to the resonant frequency so that I can get the maximum power. I'm trying to choose the second option, right? So this should not be the answer. And going to the next question, we have the gravitational constant. So gravitational constant, suppose you know only I told you what is the gravitational constant, which is solved by the universal law of gravitation. So we know that gravitational constant is having m inverse L cube t power minus 2. So first is second. Gravitational potential energy, we know that ml square t power minus 2. Everything is actually a relation. And gravitational intensity, just now previously we solved few minutes before. So this is actually given by, so gravitational field intensity LT inverse, and gravitational potential is given by L square t power minus 2, right? So on correctly marking this, 42nd option will be second. Two pendulums of length 121 centimeter and 100 centimeters start vibrating in a phase. At some instant, the two are at their mean position in the same phase. The minimum number of vibrations of the shorter pendulum, after which they are again in phase with the mean position. Okay. So let us solve this directly. We know the time period for the simple pendulum. So time period is given by 2 pi root of L by G. We know the time period equation. And let's consider this in two situations actually. So one is like N1 T1, which is equals to N2 T2. So it's like let me frame this equation by my own. So because they are trying to ask to compare two pendulum situation, which is having a length of 121 and one is of 100, and they're vibrating in the same phase. So we know that when a pendulum starts to oscillate like this, and at some instant the two are at their mean position in the same phase. So in the mean position, this is the mean position of a pendulum. See, these two pendulums doesn't have the same length, so when I try to oscillate they won't have the same mean position, but at some instant they are having the same mean position. That is what we have to find the minimum number of vibrations of the shorter pendulum, after which they again come and face with the mean position. It's like how much time after they will be coming again with the mean position. So I'm trying to equate this. So by this, if I'm trying to solve it, 2 pi n1 root of 1.21, which is nothing but the length, which is converting into a meter, 1.21 divided by the g, which is equals to 2 pi n2 into square root of 1 divided by g. On solving this, I'm trying to get the answer n2 by n1. n2 by n1 is equals to 11 by 10. So of course, we can very clearly see after the completion of the 11th oscillation, this is shorter pendulum. After the completion of the 11th oscillation, the pendulum would have get the phase with the longer pendulum, right? So the first option. A big circular coil of 1000 turns an average radius of 10 meter rotating about the axis of diameter 2 radians per second. In the vertical component of Earth magnetic field is 2.2 into 10 power 5 Tesla. The electrical resistance is given in this value. The maximum induced EMF will be. So EMF is given by the equation. So EMF, first let me solve for the flux. So the maximum flux is given by NBA cos omega t, NBA cos omega t, a general equation. And EMF, we know that is given by minus d phi by dt, guys. So EMF is nothing but by Faraday's law, it is the rate of change of flux. So on substituting this, I'm getting the direct EMF equation to be NBA omega sine omega t. If you directly know this relation, you can directly substitute, or you can get into a relatable one. So after doing this, so we know all the statements are given in this question. So trying to substitute in this, getting the answer E to be. So in this, actually we know EMF. So the question is asking for us to find the current, right? So let me try to figure out what is current. So EMF is nothing but voltage. EMF is nothing but the potential difference. So by Ohm's law, I can just say E is nothing but I into R. So I can just transfer I alone on this side, the R to that side. So NBA omega sine omega t divided by R. And we say like this, sine is 90 here because the magnetic field is perpendicular to the plane, so the sine becomes 90. So NBA omega by R we know all the values. On solving, we'll be getting the answer to be 1 amp. So NBA omega divided by R. So these formulas are very direct actually. And a few seconds, like capacitors 900 picofarad is fully charged with 100 volt battery. And this sort of questions, when I check here, so this previously were in the exams, like this models, like charging a capacitor using another capacitor, we call this to be the common potential conditions. You would have studied this. So the common potential is generally given when you try to connect this to capacitors. The common potential is given by, so VC, which is nothing but V1 C1 plus V2 C2 divided by C1 plus C2, right? So V1 and V2, initially I can just say the V1 is actually 100. So potential is 100, C1 is 900. 900, it is like picofarad 10 power. Let me keep it pico 10. Pico is 10 power minus 12 actually. Pico means. So plus V2, which is actually 0 multiplied with C2 is 900 into 10 power minus 12 divided by C1 and C2, adding these two factors, like 900 plus 900 as a whole, 10 power minus 12. So we get the common potential to be 50 volt. So this will be the common potential. And the energy stored in the capacitor is given by the expression, guys. So it is like energy. We have two capacitors here. So half CV square plus half CV square. And we should substitute the common potential here. So E is simply CV square, since half gets added up, CV square. C value is 900 picofarad. It is 10 power minus 12 multiplied with 50 square. So on solving, the energy will be 2.25 into 10 power minus 6. A nucleus of mass 189 is splitting into two nuclei having the mass number 125 and 64, and the ratio of the radius of the two daughter nuclei is dash. Okay, we know the relation between the mass number as well as the radii. It's a direct relation. So R, which is equals to R naught into a power 1 by 3. So we know this relation directly. So getting into this relation by the ideology, so R1 by R2, when I'm dividing, since it is a ratio format, so it will be like A 1 by A2 whole power 1 by 3. And initially they're splitting into like 125 and 164, 125 divided by 64 whole power 1 by 3. And we know 125 is a cube of 5 and 64 is a cube of 4. So automatically it is like 5 by 4. So the answer is 3. Yeah, we are going to finish this. And next is the topic of Wheatstone bridge actually. So in this Wheatstone bridge, they determine the value of unknown resistance x by adjusting the variable of y shown in the figure. For the most precise measurement of x, the resistance of P and Q. See, this P and Q is nothing but the meter bridge wire string, and X is the unknown resistance, Y is the variable resistance. And look on to the option, should approximately equal to 2x, should be approximately equal, and small should be very large and unequal. So when I check this word, I'm trying to eliminate this. They should not be unequal because P by Q should be same. So P by Q ratio should be equal because this should be equal to X by Y. This is the relation for my bridge balancing. P and Q, if they're unequal, they cannot be balanced, right? So this is not a figure, and they do not play a significant role. Though this is also wrong. So they play a significant role because this ratio is important for me to balance the bridge. So last two options are neglected, and should be approximately equal to 2x. And if this value, if it is like this P and Q value is relatively 2x, and it is not nothing to be going to mean me like this value should be exactly like this, nothing, there is nothing to be played here. Let us take the second option, should be approximately equal and yes, equal and on or small. Yes, this might be correct because the word here I'm checking is this should be approximately equal. Yes, P by Q should be equal. So P by Q ratio helping me to solve the Wheatstone bridge condition. So second option will be correct. The volume occupied by the molecules contain 4.5 kg water and standard temperature pressure. STP is nothing but standard temperature pressure. And if the intermolecular forces vanishes, keyword intermolecular forces vanishes away. So we need to find what is the volume actually. So easily we can find it out. So PV is equals to nRT. We need to find the V. So V is equals to nRT by P. And standard pressure for water, let me write the values. P value is like 10 power 5 Newton per meter square, and temperature is 273 Kelvin standard temperature, and the n node value is actually n is given by mass of the water, which is given in the question to be 4.5 kgs divided by the molecular mass. So water has H2O, so which means 2 hydrogen plus 1 oxygen. So totally, when I check about the molecular mass, so it will be like oxygen out of the 16 plus hydrogen is like 2, so totally 18. So the mass will be 4.5 into 10 power 3 divided by 18. So this will be the value of n here. On substituting in this, volume will be like n order value. I wrote here 4.5 into 10 power 3 divided by 18 into R order value, which is a gas constant. Gas constant is 8.3, and temperature is 273 divided by 10 power 5. So final answer will be 5.6 meter cube. So a ball is projected at the velocity 10 meter per second at an angle 60 degree with the vertical direction. If the speed is the highest point of the trajectory, see, speed at the highest point, we don't have the vertical component. At the highest point, we don't have the vertical component. We have only horizontal component. Horizontal component, which means horizontal component of the velocity is given by b cos theta, and the velocity is actually 10 into cos of 60. So cos 60 is actually 1 by 2, right? Sorry, cos, I made a mistake here. So let me just figure out the ideology here. So let me draw the projectile. So if this is a projectile, so I say it is projected with an angle 60. It is projected with an angle 60, right? So it is projected with an angle 60. A ball is projected with the angular velocity 10 meters per second and angle 60 with the vertical direction. Yes, vertical direction is 60, which means With respect to horizontal, the angle is 30. So that was to be substituted here. With respect to 30, at this maximum point, I say the velocity is v cos theta, and this theta is with respect to the horizontal direction, right? I didn't notice it. This word is very important. See this keyword, I note it down. This is the vertical direction, which means totally it makes an angle 90. So if the remaining angle is 30, so v cos theta I'm trying to find. So horizontal is v 10 into cos 30 is root 3 by 2. And when I solve this, it is like 5 root 3 meter per second, right? And the last question, two transparent medium A and B are separated by a plane boundary. The speed of light in those medium are 1.5 10 power 8 and 2 into 10 power 8 meter per second. The critical angle for the ray, okay? So guys, try to understand this. So for the critical angle condition, so I say two boundaries are there, one might be A and one might be B. Try to first find which has the greater refractive index for the critical condition and for the light grasping over the surface. So the light should enter from the denser medium and should enter to the rarer medium. Denser to rarer, we say this to be the applicable situation. And two transparent media, A and B, separated by a plane boundary, and the speed of light in those medias are 1.5 meter per second and 2.5 meter per second respectively. The critical angle for the ray of the ray, these two media. Okay, let me find. So this is a situation. So first, the refractive index of the A medium is given by 3 into 10 power 8 C by V போடுறோம். So 3 into 10 power 8 and divided by the A media is actually 1.5 into 10 power 8. So this gives me the refractive index 2, and the refractive index of B is actually 3 into 10 power 8 divided by 2 into 10 power 8. So this gives me 1.5. The refractive index of B medium is 1.5 and the refractive index of A is actually 2. So which means A has a greater refractive index. The light is entering from here to here. So this will be the angle of critical. So for which the angle of maybe I'm taking a situation. So like critical angle is equals to the angle of incidence. I'm taking the situation. Critical angle is equals to the angle of incidence, so that the light ray is just grazing over the interface actually. And if the situation is like if the critical angle, if the angle of incidence is greater than the critical angle, total internal reflection takes place, right? So we have three situations: I is equals to IC, I is greater than IC, and I is less than IC. We need to understand these three. In this case, I'm taking this situation. So what happens here is the critical angle, the angle of incidence is equals to the critical angle. So if this is the case, refractive index of the A medium multiplied with the sine of critical angle, which is equals to refractive index of B medium with respect to the sine 90 by Snell's law. I'm trying to substitute this. So on solving, I'm trying to get this critical angle sine of IC to be 0.75 and IC should be sine inverse of 0.75. So this will be the critical angle. So sine inverse of 0.750. Okay. So we discussed the key for our Neet 2022 physics paper. I hope this would have been helpful to you. So kindly subscribe our channel, right? So thank you.